Dámy a pánové, milí hosté, přeji vám hezké odpoledne.
Ladies and gentlemen, dear guests, good afternoon. Allow me to open the second session of Mendel's Days 2020. It is the afternoon of the opening day, but the opening has already taken place because at 11 some of us attended a very high-level press conference on the results of research of Johann Gregor Mendel. So it is the second time we are seeing each other in the refectory of the Augustinian Abbey. If some of you were here yesterday, I will briefly summarize what happened. We heard lectures on Mendel and other scientists. We heard lectures on Mendel's colleagues, his studies in Vienna. We saw beautiful pictures of Vienna in the second half of the 19th century. And we also heard a lecture on musicians in the Augustinian monastery in the 19th century. And we also heard songs of these musicians interpreted by the ensemble called Láska opravdivá. Today we would like to focus on Mendel a little bit more, because there's been complex research into his bodily remains, and the question stands what this research has brought to us. During this afternoon we will hear from many outstanding experts from Masaryk University and other institutions. I have no doubt that the presentations will be accompanied by discussions. In the evening, there will be a concert given by Societas Incognitorum. I hope you spend a fruitful afternoon, and now I will hand over to better speakers than myself, better scientists. First of all, Professor Šárka Pospíšilová. Good afternoon. It is a great honor for me to welcome you to this second afternoon of this year's Mendel's Days. It is already a tradition that at the beginning of November we hold Mendel's Days, but this year it is the first time that we are meeting in person. And I was looking forward to this day very much, because we want to present to you the results of several months of research into the personage of Johann Gregor Mendel. And we will take various aspects of this person. This research was initiated about a year ago, and I would like to express my thanks to all those who participated in the initial discussions, namely Senator and Director of the Observatory Jiří Dušek, and in the discussions with him, we got the idea to carry out archaeological and genetical research at the Augustinian tomb and Mendel's remains. First, this idea looked a little fantastic, and however, thanks to the support from the representatives of the city and representatives of the Augustinian order, we managed to implement all this within a relatively short time. So today we are here to inform you about almost the complete results of this research. There were scientists from various fields participating in this research. At the beginning, there were archaeologists and historians, from the Philosophical Faculty of Masaryk University and from Archaia company, which is also closely connected with the historians and archaeologists at Masaryk University. There was also a number of anthropologists working in this research. They were from the biological and molecular anthropology at the Faculty of Natural Sciences. And close to the anthropological research is the genetic research, because it is a standard today to use genetic methods for the identification of biological material. So there was a connection of several fields and disciplines at Masaryk University, and several faculties of the university were involved: philosophical, medical, and CEITEC. And I believe that this unique multidisciplinary research brought unique results. Today, during the afternoon, we would like to continue along the line of the timeline of the research. We will start with the archaeological research, and I'm happy that it will be presented by those who were present during this research in the second half of June. It's Dr. Peška and Dr. Zůbek from Archaia. Now over to these two gentlemen who will present their opening lecture. Thank you, Professor. I've never been to Mendel's Days, and I am pleased to see what an event it is, and I would like to express my thanks to the university for inviting us to this interesting work associated with one of the greatest scientists of this planet. I have to say that our relationship to Masaryk University is very close, and we've cooperated with the university for 20 years. Most of us are graduates from this university, and some colleagues lecture at the university. We have Ph.D.s from this university, so there is a very close link. Last year, we got a memorial plaque for our cooperation with the university, so it was only logical that when colleagues from the Institute of Archaeology got an application for this research, they came to us, because they deal mostly with the more ancient periods, and they knew that we had a long-term experience with research as a non-government body, and we are experienced in researching graves in the city of Brno, of which we researched several thousand in the last 5 years. It may seem at first sight that research into the grave of Mendel would be a routine job. In a way, it was, because we are used to uncovering such situations. But on the other hand, we don't always have the opportunity to open graves of specific persons, not to mention such famous persons. So we were very humble when we approached this job, and we had more scientists in the team than usual. We were addressed for this cooperation because at the central cemetery there's the Augustinian tomb, and 2 years ago it was renovated, and the Monument Institute was afraid that the monument would be damaged, and we are experienced after all, because we are used to working on landmarks and cultural monuments. So we accepted this assignment. First, we had to create a design of the whole project and of the situation around the grave. We had to prepare for the movement of the tombstone, and the reason why we chose the archaeological method of collecting the remains was that in the grave there are another 4 brothers in this specific grave, and it was necessary to have someone who is familiar with the exact scientific methods. So we had Dr. Zůbek and Denisa Fojtíková, who cooperated on the processing of the findings, and the team also included people from the 3D documentation department.
I would also like to mention the colleagues from the Department of Science and Chemistry who are not here and who promised us to restore and analyze the remains and also the remains of the textile which we found in the graves. So it was a complex project. We succeeded in securing the tomb and start with the research. And now I would like to hand over to Mr. Zůbek, who was working in the field. I will guide you through the presentation, which will be in front of you and which will show you the details of the archaeological research, which actually I think is not so much interesting as the results of our colleagues from the anthropological team and genetic team. So my presentation is more or less of a technical character. I will present how the Augustinian tomb looked during the research. So I will comment on the pictures in front of you. It will be a detailed analysis during the process in the field. And in conclusion, my colleague from the university, Denisa Fojtíková, will give you a short comments on the mobiliary which we obtained from the graves. Here you see the layout of the tomb within the central cemetery. Those of you who are from Brno, you must know the cemetery, and this is the basic orientation of the tomb. It is in the eastern part, in the corner of the tomb. According to the gravestone, in the grave pit, apart from Mendel, there should be also Alois Slovák, Gregor Johann, and Ambrož Drábek, who were gradually buried in this pit. Our expectations during the research were different. I will give you more details later on. Were not fulfilled. The whole area needed to be secured against the weather. Very important was to have a proper static, not to damage the tomb. Here you see some examples of the stiffening of the grave pit and so on. Here are a few pictures of the personnel working in the pit. This was a mixed team. We were closely connected with the anthropological team, and the works were done under strict conditions, safety conditions. I'm not speaking about our health, actually, but when I speak about the safety, it was about the safety of the anthropological material, because we didn't want to contaminate the DNA remains, the DNA in the remains. So this is the first funeral. According to the methodology of our company, we usually number the funerals. So this is number 800. He was a anatomically buried person in a wooden coffin. We collected his remains. Here, specifically in this picture, Anthropological team will speak about that in more details, but this is an example how we sample genetic material from the skull and lower jaw. This is step by step how we excavate the remains, and at the same time we need to prevent the remains from contamination. In the final part of this excavation, only then the sample was collected by a specific person. One more picture from funeral number 800. The lower picture is a 3D visualization, and all the funerals and coffins have been documented so that we are able to use those documentation in the future. The next funeral, numbered 801, refers to the skeletal remains in anatomical position. They were laid on the cover of a metal coffin from the following funeral. Again, the collection of anthropological material. And here, finally, we see a metal coffin on which the remains were lying. During the research, some members of the research team who was involved in the project started with a celebration or celebrated our achievement because we thought that this is the coffin of Mendel. But from 1 minute to another, the celebrations turned into the complications because it turned out that this coffin is not Mendel's coffin. And it was quite clear that he is in another coffin. And then the project started to be more complex because we needed to secure everything from the archaeological point of view. I'm speaking about the technical conditions, how to collect the coffin undamaged, and so on. From the technical point of view, I need to add that the biggest problem was to secure the pit, because we found out that there are several graves, one above another, and several times it happened that we needed to enlarge the pit, and we needed also to stiffen or stabilize the tomb, because 3 years ago, when the tomb was reconstructed, the walls of the tomb were stiffened, but still it was a complication which we needed to face. Again, some pictures of the coffin from funeral 802. The coffin was transferred to the premises of the central cemetery to a special room because we needed to secure special conditions. Some pictures in front of you. The colleague forgot me there. The final archaeological interpretation was quite complicated because apart from the anatomically buried person, there was one more person in anatomical position as well, which I will speak about later. The main objective of the research was to find the coffin with the remains of Johann Gregor Mendel. Now I can tell you that this is the coffin in question. I'll give you some more details. If you see the small square, we thought that the remains might have been collected from the coffin and the coffin could have been empty. So we made a wall, we made a hole into the coffin and we used the camera and we found out that the remains are inside. So therefore we decided to collect the coffin. And we knew that this is the last grave because under this coffin there was just the soil. So this was the most complex situation, collection of the coffin which we experienced. This coffin reached outside the archaeological layout, and the grave of Johann Gregor Mendel was actually covered by the foundations of the Augustinian tomb, because it was built a bit later. So you can see that the cover is pushed down, and there is a soil on it. So 2/3 of the coffin were under the wall, and only 1/3 of the coffin was in the grave pit. So that was the most difficult part of the work. So we discussed the whole situation with the designers and colleagues from the technical faculty, and we used steel needles, 25 pieces of steel needles, which secured the lower part of the pit, and only then we started with very demanding process of taking the coffin out. Because the most problematic part was to get the coffin outside in the whole piece, not damaged. Finally, we succeeded. So we took a time-lapse video which can give you more details how we did it. We did it together with Mr. Kolářík, who is an expert. So as you can see, the coffin had 6 legs, which was quite difficult, because once you break the leg, then it is difficult to pull it out. Finally, we bought some boards or planks, which we put under the coffin, and under those boards we inserted longitudinal boards to be able to lift it up. So it was a very complex procedure. The whole thing took us about a day, the whole day. But then finally we were successful in lifting the coffin up. We were a bit afraid when we saw the length of the coffin, because the stiffening part around was only 2 centimeters wider, so we were lucky. But as you can see, we got the coffin up. And then we took the coffin to the cemetery, to the special room in the cemetery, and we gave it to the anthropological team. And this is the open coffin.
Archeologické interpretaci té nálezové situace, tedy to, co se mělo povést, se podařilo, takže ten vlastně nejočekávanější výsledek byl, nebo ten cíl byl najít ostatky Gregora Johanna Mendela. Za archeologii samotnou, když nebudeme počítat výpověď archivních pramenů a antropologických, tak poměrně jednoznačně ta situace potvrdila, že se jedná o tu rakev 804. Tam ty důvody byly jednoznačné, protože vlastně Gregor Johann Mendel byl pohřben dřív, než vznikla augustiniánská hrobka, proto se ta rakev nacházela pod základy té hrobky. Otázka, proč vlastně asi ty dispozice nebo ten vývoj toho prostoru.
It was buried under the foundations of the tomb, so it gave us the proof that this is the coffin of Mr. Mendel. The coffin, in the coffin there is a piece of newspaper from 1883, which we call Postquem. I think this was the newspaper from October, and Mendel died in January 1884. So the newspaper was used to fill up the coffin. So we assume that they used the newspapers from the period of the time when they buried the body. Well, archaeology is never a 100% science, but when taking into account the legal point of view, all the evidence was very persuasive. So we can say that the project has won. We completed the objective of our project. We were also interested in other persons who we found in the grave, and the number of the persons does not match with the names on the gravestone. The archaeology needs to perform more research into this matter.
We will hear from our colleagues from the anthropological team, and we will probably find out more. I think we can certainly say that the first burial in the wooden coffin was the last person on the tomb, written on the tombstone, Arnošt Drábek. Moving on, these are pictures of Mendel's coffin. You may not see well, but these are the indications for our interpretation. In the right-hand part of the slide, there is the fragment of the newspaper showing the date. This is the part. This is a part of the possessions which were found in the grave. This was also mentioned during the morning lectures. And now I'd like to hand over to Denisa Fojtíková, who was responsible for this aspect of our research. I will just add one piece of information. For quite a long time, this was left at the morgue, and part of the findings are being analyzed at the Faculty of Natural Sciences. Some parts will be restored, some will be analyzed, and some will be reburied. I will tell you a few words about the objects found in the grave. In the first grave, in the wooden coffin, we found a wooden cross, and the images you can see are before the cleaning of these objects. And in the first grave, we found a metal cross, which belongs to the traditional burial objects in the 19th century. We also found shreds of clothes and a leather belt. In the grave and in the first metal coffin, we found a fragment of a collar, which is also a part of the traditional vestment. Then there followed the first metal coffin, in which we found two individuals. There were more objects. The anatomically positioned person was dressed in a robe, which is typical for the Augustinian order, and on the shoulders he was wearing the expository with the buttons, and in the hands he was holding a wooden cross with the metal pieces and a metal sculpture of Jesus Christ, and he also had a metal sculpture of Jesus Christ, but of that of the wooden cross, there was only dust. And he was also wearing a belt. And the interesting thing is that he also had stole, which is typical of Augustinian abbots or cardinals, bishops, and the Pope, or it can be also worn by important persons. So this is why we believed at the beginning that this could be Mendel. However, his pectoral is positioned in the museum. This individual also had a lace cushion, and we also found preserved shoes. So these are the shoes and the cushion and the robe. These are Mendel's possessions. We expected we would find more since he was an abbot, but unfortunately we didn't find anything more. He was wearing a robe and an expository on the shoulders with the buttons. He was wearing shoes and he had knitted socks. And the most interesting object was the newspaper. Unfortunately, this is all, because everything else that he possessed and that he used are exhibited at the museum. So this much we have about the findings, and we will continue with the analysis of these objects for another 1 or 2 years. With respect to the objects and to the project itself, at the press conference it was not mentioned, but I would like to thank the administration of the Central Cemetery and its director, Mrs. Říhová, who helped us very much, and thanks to her, the whole project went very smoothly. We were late by only 1 week, and it was not so bad. So this was our brief introduction of the research into the grave, which usually is a routine affair, but in this case there was this special spirit since it was a grave of Mendel. This was the first time for us at the Central Cemetery, and with jobs like that, there's always some pressure and a lot of expectation from the public, and fortunately we managed. In conclusion, I would like to show you very short videos of 3D documentation from our colleagues from the Department of Museology and Archaeology.
Už by to mělo jet. Tak to je první. Toto jsou přímo ostatky.
These are the remains of
tak jak jsou zachyceny po
Mendel,
3D montáži.
Captured after the 3D
video, jo, není to
capture. This is not typical video camera. This is digital image, and I think it's of very high quality, and our colleagues from the Department of Museology and Archaeology are real experts, leading experts in the Czech Republic. Here is another video.
Omlouvám, to jsou ty technické obtíže někdy. ale zase bylo škoda to nepředstavit. Myslím si, že ty 3D
I believe that 3D visualization are very good for displays in museums and for time-lapse videos. The archaeological research, in this case, in the end, we were able to confirm that the remains were Mendel's, and maybe our archaeological research was not so important, but in any case, we were able to complete the whole documentation. Thank you. And we will be looking forward to our colleagues' lectures.
Ještě prosím zde vydržte pro případnou diskusi. Já bych chtěla hrozně moc vám všem třem poděkovat za přednášku.
I would like to thank you all for your lecture and namely for the implementation of the research. I was really very enthusiastic about the cooperation of all the teams. And it was especially thanks to you that we were able to perform the first part of research. Without you, we wouldn't have been able to carry on. So thank you, and thank you goes also to Mrs. Šíhová from the Central Cemetery Administration. Now we have a few minutes for discussion, so if you have any questions or comments. A question for Mr. Zůbek. We can talk about it in the office, but I will ask anyway. So, Johann Gregor Mendel was not wearing a pectoral? Because I was wondering whether an abbot could possess two of them, but he was not wearing his pectoral cross. What will become of the remains afterwards? Following the exhumation, the remains were transported by archaeologists for further research in the lab of biological and molecular anthropology at Masaryk University, and in the next hours they will be reburied in the Augustinian tomb in the presence of the highest representatives of the Augustinian order who arrived from Rome for this occasion. So the skeletal remains will be buried again, and along with them some of the personal possessions will be also buried. It will not be researched any further. And based on a permit from the city of Brno and based on an agreement between the Augustinian order and the archaeologists, some objects will be further researched. And this will happen at the Department of Chemistry at the Faculty of Natural Sciences at Masaryk University. Who was the person which was not expected in the grave? Is that known? This is an interesting question. Of course, we were interested in the identity of this person, and I believe Assistant Professor Drozdová will speak more about it. There's a hypothesis that it was Father Nap, that means the abbot who was the predecessor of Mendel, and for many years he was the abbot of this Augustinian monastery. There are some indications that this was the found person. This would be documented by the found pectoral cross, but we will work further on obtaining further evidence, including genetic evidence. So if there are no further questions, the team will be available for any questions later on, and we will move on to the next lecture. And the lectures will be on the anthropological research of the bodily remains, and the first speaker will be Assistant Professor Drozdová, head of the Molecular Anthropology Laboratory at Masaryk University, Faculty of Natural Sciences.
Vážené dámy, vážení pánové, dovolte mi, abych vám představila...
Ladies and gentlemen, allow me to introduce the anthropological part of this research of the Augustinians. I would like to follow up to the archaeological research. I work in the Laboratory of Molecular and Biological Anthropology at the Institution of Experimental Biology at the Masaryk University. I am speaking on behalf of the team whom I'm a leader, but there were many employees and students who cooperated or participated in the research. I have some names here. These people were not only our employees, but also graduates, for example, the colleague who works in the Moravian Land Museum in Brno. The research, as you have heard, was focused on the research of genetic information and anthropological research of skeletal remains. And our objective was to examine the grave of Mendel to find and identify his skeletal remains and to obtain genetic information. We worked in a close cooperation with archaeologists. It means that from the very beginning, from the 14th until the 30th June 2021, we were working together in the field in the Central Cemetery. And we worked with the skeletal remains which were found at the very beginning. Even before we started with the field research, about 3/4 of a year before that time, we performed a research in the Abbey and in the Mendel Museum. And we examined the personal possession of Mendel with the objective to obtain his genetic information. This topic will be discussed by my colleague, not me. Here you see the picture how we worked, either directly in the grave. Here you can see our colleagues, archaeologists, who worked in protective clothes to prevent contamination by receptive DNA, or we work in the morgue to exhume skeletal remains which we found in metal coffins. Here you see the the participants of the commission. We met every day and we assessed and evaluated what has been found and our next steps. Here is the first metal coffin in the morgue. And the conditions, how we work, it was air-conditioned room, air-conditioned to such temperature not to damage the remains. and also there was a comfortable temperature for the researchers. The room was opened only for the researchers in a special suit. We took the samples for the genetics, and only then we allowed other people to access the skeletal remains, but always with more or less protection, protective clothes and so on. And we worked on the exhumation of skeletal remains. We tried to identify the persons found in the grave. Originally, our theory was based on the gravestone in the tomb. There are names of the people who were buried here. First of all, Johann Gregor Mendel, then Aloysius Slovák, Gregor Jogl, and Ambros Drábek. So that was the first hypothesis of ours. But on the contrary to our expectations, we found 4 coffins of 4 persons. 4 persons who were buried there, and including their skeletal remains. But then we were surprised that in one coffin, we found 2 persons in one coffin. This is the coffin with the 2 persons. This is the head of the second person, man. This is the primary person who was buried here in a robe, his skull, his hands and extremities. And next to him, you can see the second skull, which was badly damaged. And on the surface, there were some more bones, which were just laid there. We could see that these are only bones, it was not the whole person when it was put into the coffin. But we also found in the coffin some more objects, mummified tissues, saponified fatty tissues, fragments of the tissues, nails, axial hairs, tendal prosthetics, and prosthetics, and also some more shoes and clothes and so on. We spoke to the Augustinian representatives because we wanted to identify the 2 persons buried in the coffin, because we didn't know who it was. I assumed that it was Aloysius Slovák as a main person, plus 1 more unknown man. But the brothers persuaded me, because when they showed me the extract of the birth register, it was quite clear that 1 more coffin was brought to or buried into the tomb with Cyril Knapp. Alois Novák died in 1906, so that was the last person to be buried here before the next coffin was brought out. So it seems that the buried person with the insignatures of the abbot was really in the coffin together with the remains from 1896. Alois Slovák has been deprived, has been in the coffin. You will see it in other slides. When identifying the persons, I started with their age, calendar age, then biological age and other indications, and also from the register of the birth. Now let's have a look at the individual graves and skeletons which we collected. Let's start from the upper part, so it is the youngest funeral. High probability is that it was Alois Drábek who died in 1945, and he was buried here. Unfortunately, still I do not know, because we are still ongoing with the research, I still do not know the details, so I don't know the details about his age. However, his name is Ambrosius Drábek. He was buried in a wooden coffin, which is good, because the coffin was decomposed, and the body could decompose as well, and skeleton was well preserved, and the body was actually consisted only of the bones. Here you can see a photo of the entire skeleton as it was preserved. You can see an excellent condition of the skull. It is not damaged at all. I need to compliment my colleagues archaeologists because they collected everything. So this is a part of the tongue bone, very tiny bone. Upper extremities were sort of damaged. There were no epiphyses. The spine was damaged as well. There are only several vertebrae and ribs, but we had well-preserved lower extremities and all the bones from the lower extremities. Here you can see his skull. When we cleaned the teeth, we saw a nice prosthetic work on both jaws. This is an X-ray scan as well, which depicts the temporal holes. We also determined the biological age, approximately 63 years, and height 167 centimeters. As the skull was well preserved, we could also estimate the capacity of the brain case, 1,320. Here you can see the dental prosthetic. These are the samples in the microscope. We use the electron microscope as the X probe, and we found platinum and also gold in many of the samples. So this is a nice dental work of that time, actually, and it's very rare, very not usual. The next person who was buried without a coffin we went down after the first coffin, and all of a sudden we found some bones, and when we continued in digging, we found a skeleton without the grave, which is lying next to a metal coffin. This skeleton was the best preserved one. As I said, when there is no coffin and no deteriorating conditions which enable decomposition and so on, the soft tissues are decomposed very quickly, and what remains is only skeleton, which is usually well preserved. You can see the pit, and here you can see the skeletal remains from the top. However, the skull is deformed. It means that it was pushed down by the soil and it went deformed. So what remained was the brain case, no face part, but we have a nice lower jaw. I don't need to describe it, but you can see yourself that the skeleton is well preserved. And what is missing here, these were taken as samples for genetic analysis. And this is a detailed view, a skull, which could not be measured because it was badly damaged. The shape was damaged. Georg Johann was his name, and he died at the age of 75. The biological age, 72, and it corresponds to the parameters which we monitored. First of all, tissue structure in femur and humor, and you can see that he was without teeth. He was toothless. It was proven also in the X-ray scan. He had gerontic changes on the spine. This is the thorax part of the spine. So all joints were actually affected by gerontic changes, and he was toothless. His height was about 167 centimeters plus minus. And now we come to more complex cases. This is the first metal coffin. When we collected the remains of Gregor Johann, we also found out that there is a metal coffin which was collected directly from the grave, and we transferred the coffin to the morgue and we start with the exhumation. This is my chart or drawing which I drew, which I prepared in the field. And here you can see the two skeletons. The main person is buried in clothes and he is lying in an anatomical position. It seems that the skull is nice, or is well preserved, but in a while you will see that it is not. The bones of neither of these two people are not well preserved, and on the clothes of that person there were some more bones, the individual bones of the second person who was buried there. He had cushion under his head, and there were the larvae of insects around his hair, and you can see the second head next to him.
Tady to vidíme už potom.
This is the grave from which we already collected the remains of the first person, whom I believe was Aloysius Slovák. And these are the skeletal remains of the main person, and we still need to prove this, but we believe it's Abbot Cyril Knapp. And it is all very brown, so we can't see very well, but you can distinguish the shoes and the clothes and the hands in the lap. And this is the skull. Only a part of the facial section was preserved. This is a CT reconstruction, and you can see very well that there are intravital losses. Not all of the teeth are present, but the teeth are very well preserved and not much consumed. It means that he was not that old biologically, and there are osteophytic margins, so there are obvious changes associated with old age. And in the pelvic area, we found a lot of saponified fat. The left femur was interesting because there was a fracture which healed with false joint, so there must have been a lot of friction in the joint. This is an X-ray of that place, and this is an image from computer tomography, and this is reconstruction. Abbot Knapp used a walking stick, and it is a known fact that he was lame. So it is very likely that these skeletal remains were those of Cyril Knapp. These are other objects found in the grave. You already saw the pictures, and these are the larvae. And we have samples of all of them, and these still wait to be analyzed. This is the cushion on which rested the head, and this is the second head of the second individual. These are the findings, and this is the robe, which was very well preserved. This is the second person. As the bones are brown, you can't see very well, but this is the tibia, this is the second tibia, this is the humerus, and scattered are some smaller bones, like the radial bone and so on, and this is the skull again. And this is my drawing. In red color, I tried to show the positions of bones, those belonging to the second individual. And this is the level of preservation. You can see it is not very good. The skull is decomposed and it crumbled. But the mandible was very well preserved, and the rest of the bones were decayed. This is a closer inspection. These are remains of hair. This is the temporal occipital bone and remains of hair. A lot of mummified tissue is usually found in the coffins. Even though the bodies are not mummified, some of the parts were very well mummified. And these again are the teeth, and the biological age was 40 to 50. The height was 163 centimeters, and this is the sternum. And again, we can see the saponified fat. This is a black layer, which could be the rest of lung tissue, but we will have to analyze this. And this brings me to the highlight, and that is our desired Johann Gregor Mendel. You saw the coffin. Once again, we are back in the morgue. We were assigned a very nice room, which was air-conditioned, and it had these boxes. And this is a view of the coffin of Mendel. There was only one person, again, wearing something very similar to what we saw in the previous pictures. And we worked on this. This is a box with the skeletal remains or parts of the skeletal remains. It was necessary to collect them in a way that did not damage the clothing. So we had to work through all the remains very carefully. These are the shoes. We measured the size of the shoe. This one is deformed, but this one is well preserved, or with a well preserved sole, and the length is 27 centimeters. This is the robe and some kind of fur which he probably wore around the neck. And this is the entire robe. And it is placed in an effort to preserve it for further research. These are my photographs of the newspaper. The newspaper was already mentioned. We all took pictures of it. And these are the skeletal remains of Mendel. You can see that the skull is very well preserved. Both jaws are toothless. There are only 2 remaining teeth. There are 2 teeth on the lower jaw, but apart from that, everything is well preserved. Even the processus styloideae is very well preserved, and the whole body is excellently preserved all the way down to the waist. From the waist down, it is worse. When we touched the femur, it crumbled, and os pubis was missing, and the tibia were all broken up, and the distal ends were broken off, and it was falling apart at the touch. When we collected the coffin, it contained water, so the conditions in the ground were not very good for the preservation of the remains. And it is in the slope, and probably one part of the coffin provided better conditions for the preservation of the body. To our great surprise, we found this tooth replacement. It was made of rubber. We analyzed the material and we used EDX probe, and this is an image from the microscope, and this is an X-ray, and these are platinum wires, which we also analyzed. And now we know that they are platinum. And there are 3 premolars. There are no molars, but 3 premolars. And there were 2 molars here. They were preserved, and they used as an anchor for the replacement. And however, we were unable to place the prosthetic back into the mouth. Some soft tissues were also preserved. From the shoes, we were able to retrieve remains of fingernails. This is a toe, one of the toe fingernails. And in the ventral area, we found saponified fat. This is a clump of the fat. And this is also saponified fat from the lower aspect and from the upper aspect. And there are also some hairs from the belly area. As I researched the skull in the lab near foramen occipitale magnum, I found remains of brain tissue, and we have these samples along with the saponified tissue, and we will further analyze all this material. Since the skull was so well preserved, I was able to measure the brain capacity of Mendel, and it was above the average of the current men. It was 1,580 cubic centimeters. The height was estimated at 168 centimeters. We analyzed all of the skeletons in the same way, and even in this case, you can see the X-ray images. This is also a CT image, and you can see the forehead cavities, which are large, and this is an atrophy of the alveolar crest. All the skeletal remains of Mendel were 3D scanned, and this gives us an opportunity to study them further in our computers. And this is an example of some of the parts of the skeleton. This is just so that I don't show you only the skull. This is the shoulder blade with the remains of skin. All the dark spots are skin. This is once again the hyoid bone, and it is very well preserved. It is a larger half. He also had an ossified thyroid cartilage. So this was just an example of our research work, and this will continue, and we will have more results. We had the skeletal remains at our disposal for only about 3 months, and we had to prepare them for research. We had a lot of time in a way, but we had to work very quickly on collecting data, and we were unable to analyze everything properly. So now we will work on the analyses. We paid equal attention to all of the skeletal remains. We didn't focus solely on Mendel, and now our work will continue. Before I finish, I would like to express my thanks to all those who participated in the research, and they were not from my workplace or our related workplaces. I want to thank the representatives of the Staré Brno Abbey and the Order of St. Augustine, who helped us very much and supported us very much. They attended our sessions, and they were very interested in the results of our work. Thank you. I want to thank the representatives of Spolu, who were responsible for our contacts with the Abbey, and again, the cooperation was excellent. I want to thank again Mrs. Říhová, from the Central Cemetery who helped us with the collection of the remains and who helped us to work in a dignified way and who provided the morgue for our efforts. I also want to thank the workers of the radiological clinic at the Brno Bohunice University Hospital. I want to thank the team of microscopy for biomedicine at the Department of Technology at the Academy of Sciences, and Jiří Pec from 3D Studio at the Faculty of Fine Arts at Brno University of Technology, who 3D scanned all the remains without asking too many questions. Thank you.
Já bych chtěla také hrozně moc poděkovat paní.
Thank you very much, Assistant Professor Drozdová, for all those remarkable findings. And I'd like to ask you, or could you please specify all the methods that were employed? Are they used in other similar anthropological research, or did you use any non-standard methods?
We try to improve our methods and we try to use them as a standard. So what we used, or which methods we use for this research, we also used in the past. But now we have a new X-ray, so we made about 1,000 scans, and we have a special laboratory for DNA isolation, and we also exerted a great effort to collect all the genetic information from the remains, and we cooperated with CEITEC as well. We have some time for questions now before the next presentation starts. Veronika Slámová. I would like you to specify how many people participated in the research, how long, and at a press conference it has been mentioned that about 30 objects have been found. So are these objects from all skeletal remains, or it belongs only to Mendel, which I don't think is the case. About 30 pieces are all the objects which were found during the research. It means from the grave pit, in which there were 5 funerals. Regarding Mendel, there were only few objects. As for the names you mentioned, or people participating in the project, biological, molecular anthropology. Well, the team consisted of Mrs. Fialová, who will be the next speaker, then Eva Chocholová, Anna Šenovská, Kateřina Novotná. These ladies were working in the field. We were all working in the field. Mrs. Fialová worked with the entire project because she's a specialist for genetic information. So she also participated in obtaining genetic information. And Ilona Šťastná is our lab person, who was our long hand actually. Kristina Brzobohatá is another person. She also participated in obtaining genetic information. And Vaničková works in Moravian Land Museum, and she also provided for 3D scan of a skeleton. Thank you for details as far as the staff who participated in the project is concerned. If there are no more questions, I would like to hand over to Mrs. Fialová, who works in the same institution, and she will speak about molecular anthropology. Good afternoon. As mentioned, I will continue with the details from our laboratory. Again, you can see our colleagues from the lab who participated in the project. Now I would like to present a molecular genetic part of the analysis. As this part started, now we have October or November, so it started a year ago. At that time, in cooperation with the Mendel Museum, Masaryk University, and the Museum of Old Brno Abbey, we collected material that was somehow connected to the life of Gregor Mendel. So we collected samples, and as you can see, it was a sort of a detective work. That is a picture of my colleagues. You know exactly the names of those colleagues who are not only from our lab, but also these are the colleagues from CEITEC. So we took the samples or swabs from the objects which belong to Gregor Mendel. And especially, we collected the samples of hair and facial hair from his favorite books. Specifically, we researched 2 books. The first one was the book about the origin of the species by Darwin, and the second was the book about or on astronomy from 1825. You see the steps, how we proceeded. We needed to meet strict anti-contamination measures to prevent the objects to be contaminated by our DNA. We were given a room in which actually we had a sort of forensic research. I was taking a picture, and my colleagues are wearing overalls and respirators and double gloves and other protective clothes to prevent their own DNA, to prevent that their own DNA could not or cannot contaminate the objects. Here you can see how we took the swabs from the glasses of Mendel or fingerprints. Not only had we these 2 books, but also some other documents in which we quite often found a visible in our own eye fingerprints. This is an example of the collection of the hair from favorite books. The point is that those books were very thick, about 600 pages. So we went one page after another. And we needed to search for the hair, and if we found any, we needed to use sterile tubes to collect the samples. This is the picture from the sampling. Mrs. Brzo-Bohatá is sampling the samples from the microscope. This is the glasses case of Mendel. Altogether, we sampled 27 samples of those hair and facial hair samples. So we thought this is a hair material. So we took everything what looked like a hair or facial hair. So 16 samples from the book Astronomy and 16 from the Darwin's book. Then we have 41 swabs from different objects, which we will analyze in the future. So as for the hairs and facial hairs, I need to say that analyses are very expensive. So it was recommendable to have a look if it is a hair or a facial hair. You can see that we use the microscope in our lab. And again, you see that, again, we needed to meet a very strict anti-contamination measures. Only one person could be in the room, and the room was modified accordingly. Accordingly, it means even the microscope needed to have UV, including the glasses and chemical substances which we used. So everything was done with the aim to prevent the DNA to be damaged. So we had special conditions. If you have a photo taken from the microscope, then you have a piece of information, because then when you carry out molecular or genetic analysis, this is considered to be a destructive method, and then we would not be able to look at it retrospectively. So we took 5 samples of this hair material from one book and 9 samples from the second book. These are the photos of the samples from the microscope. This is the hair found in the Darwin's book on the origin of the species. This is a facial hair beard, which has 3 roots actually, which is quite exceptional to find a hair with a root. So we were so much excited when we found it, because we knew that we will isolate a large amount of DNA. And the rest of the hair material was without the roots. I also want to show you the next picture. You can see that all the fibers are interesting for us, but for our purposes we needed to exclude them because, for example, green or red fiber from the clothes, it's not usable for our purposes. And you can see also there were leaves of tobacco and a fly, for example. So we could then continue with the selected samples of hair, and all the work was done in our laboratory. The important thing is that this laboratory, this lab, is a specialized room in which we only analyze ancient DNA. And again, we need to meet strict anti-contamination measures. This is the only workplace of that kind in the Czech Republic. As I said, we only concentrate on ancient DNA. There is no recent DNA. And everything is adapted to the objective of this lab. Access to the lab, everything, clothes, everything. So what we did actually, we needed to prepare ourselves for the sampling. We needed to clean everything. I'm not talking only about the samples of hair and facial hair, but I'm talking about all the samples from the field as well. Next step was decontamination of the samples, then isolation of DNA in flu box. DNA can be amplified, and in that point, in that step, after amplification or propagation of DNA, then we do not need to have the sample in our labs. So in the next step, we prepared the libraries for the sequencing of DNA with our colleagues from CEITEC. But to be able to isolate any ancient DNA from hair, We needed to exert much effort because it was a big challenge for us, because there is no easy protocol how to isolate ancient DNA from hair. So there are some projects and works which succeeded. You might know the work Identification of Nicolaus Copernicus, and several days old information about the isolation DNA from the hair of the sitting bull. But in that specific case, they did not have only one hair available. So we needed to optimize the procedure for isolation. And we did it on the hair which we had from the 17th century. So we knew that the new procedure which we created will be working. We hoped it will be working for the hair from the 19th century as well.
Já jsem vám říkala, že vlastně
I already mentioned that we found out that with the hair, we only had 3 hairs with roots, so we needed to concentrate on the mitochondrial DNA, because mitochondrial DNA in the hair is well preserved even though the hairs do not have roots. It is generally better preserved because each cell in our body has mitochondria which help us to breathe, and there are several mitochondria, and in each one of them there are several copies of the mitochondrial DNA, and therefore in the total count we have a much larger possibility to isolate mitochondrial DNA. Since the structure is circular, it is better preserved and it resists decay. And it is because generally ancient DNA is very fragmented and very degraded, and there are many alterations. And another piece of important information about mitochondrial DNA is that it runs in the maternal line, and there are fewer pairs of bases than our genome. Thanks to that, we could, or they at CEITEC were able to sequence the whole mitogenome. And this paid off because out of 14 selected hairs, we successfully retrieved mitochondrial DNA, that means the entire mitogenome, in 6 samples. And this is why we were able to identify the mitochondrial haplogroup. And in 5 samples, it was identical. It was W6. And in 1 sample, it was different. It was haplogroup H1C. And you may already sense where I am aiming. Clearly, this specimen was from another individual than the remaining 5. Now I will leave you or keep you suspended, and we will look at the isolation and processing of ancient DNA from the skeletal remains. I am demonstrating here that all of the skeletal remains were collected in a sterile way, so there is no foul play here. And this is the collection of specimens from the first individual. We took samples from all individuals in this way because we were not sure what the situation was in the grave, and we didn't know exactly who was who. And naturally, we had to take all the samples and we had to identify the mitogenome of all of the individuals. A colleague is holding a jaw here, a jawbone without teeth. In our analysis, we concentrate on the teeth, and if we didn't have any teeth, we took samples from long bones. This is us opening the first tin coffin, also wearing the overalls and taking all the precautions because we didn't want any contamination. Here I am taking a specimen from the first individual, from the lower jaw, and this is probably a button-up. On him, as we saw in the drawings of the previous speaker, there were several bones on top of him in a non-anatomical position, so this was another individual. And in the middle of this chaos, we identified another jawbone of this individual, probably of Mr. Slovák, and this is where we collected the jawbone. The deepest in the grave was the coffin of Johann Gregor Mendel. Here I am with my colleague trying to open the coffin. We didn't succeed at first, so we invited more colleagues and we instructed them to wear all the protective things, and we prevented the contamination with recent DNA. And this is me taking the first samples. And here I am using tweezers to take the tooth, and this is the mandible, and this is where it is already placed in a bag. All of the specimens were placed in the refrigerator immediately in order to preserve the DNA in the highest possible quality, because it is a DNA 200 years old, so we didn't want to add any trouble to it. So in the fridge, all the samples were taken to our lab, where they were placed in the fridge or in the freezer. By freezing, deep freezing the samples, we are able to stop any processes, any undesired processes such as oxidation, hydrolysis, and so on, because we want to avoid the fragmentation of DNA. So we took all the material to our lab, and following that, in sterile conditions, we took samples. And now I will concentrate on the molecular analysis of the skeletal remains of Johann Gregor Mendel. We took samples from the bone, from the roots of teeth. It was from 5 teeth in total and 1 bone. It is recommended to take samples from 2 different tissues in order to verify the results. You may be asking why so many roots. First, we tried to obtain the mitogenome to confirm the haplogroup, but we needed a high-quality isolate in order for the colleagues at CEITEC to be able to sequence the entire genome. So, collection, decontamination, pulverization, that means creating powder from the bones and teeth, isolation of DNA. We did amplification, or the first part of the preparation of the library, and then it was up to our colleagues at CEITEC who sequenced and finalized the processing of the data, and you will hear the lecture on the genome. When we obtained the data from colleagues, we processed the sequencing data from the mitogenome, because this is important. This is ancient DNA. It is not regular undamaged DNA. We need to apply several bioinformatic tools, special software for ancient DNA, which, for example, detects how much the DNA is damaged. It's map damage software. There are other, but in this case we used map damage. We used other software as well, but the point is that this software tells you how much the DNA is damaged. And it's not just information that it is damaged, yes or no, but it gives you information that since it is so damaged, it is evidence that it is ancient. So it cannot be from someone who just entered the space or someone that you could take samples from recently. And if you use other software, such as HaploCheck, it is something used to rule out any contamination. So this is the result of the coverage of mitochondrial DNA of hairs and teeth, because we were able to compare. This is the hair, which came out as a different haplogroup, H1C. It was from the first unnumbered book on astronomy. And this is a picture from our analysis, and it shows that this is actually ancient DNA because it is so damaged. We did the same with the tooth, and this level of damage was not so high. In any case, despite all this, we managed to cover the mitogenome at the level of 99.8%, both in the hair and in the tooth. So this is coverage along the entire mitogenome, as you can see in this diagram. So we could compare. You cover the mitogenome. It means that you find polymorphisms, some mutations, against the reference. And now we are comparing two samples, the hair and the tooth, and we confirmed that there was a match in 12 polymorphisms. It means in the entire mitogenome we had 12 mutations where there was a match. And if we calculated the probability that in the global population there is a person with the same combination of polymorphisms, it is a very low probability, approximately 1.28 times 10 to the power of 9. So if it is not a direct relative of Mendel in the maternal line, it is Mendel, if it is not his sister. It is coded here, but we have a specific list of polymorphisms, and behind these numbers there are specific mutations where there was a match with the skeletal remains. And in this column it says what is the percentage of occurrence in the world. And this is what helped us to calculate the probability. And this is the discovery of the one hair, which we identified as Mendel's. It is the first unnumbered page of the book on astronomy. It is a popular astronomy book from 1829. It is the first page. And here at the margin you can see the hair. It was captured in the structure of the page in a very interesting way. And there are some prints. It was originally in a different place, but it was easily retrieved. And since we did also a microscopic analysis, we can actually see that it was a hair, 50 micrometers wide. It is brown. You can see the internal structure of the hair. But the thing is that one of the roots is cut off, or sorry, one of the end is cut off, and the other end is ripped off. So this hair did not have a root. We compared the two results, and the result is haplogroup H1C. My colleagues will talk about it further. And we used other instruments to identify the haplogroup, in this case the mitochondrial haplogroup, which is the most common group in Europe. H1 is the most frequent haplogroup in Europe. It is the typical European haplogroup, mitochondrial. And if we look into the history, it can be found in the databases of ancient DNA, and this specific H1C was present in the Neolithic age, Bronze Age, all the way to the present day. These are pictures from another database that gathers the results of the current mitochondrial haplogroups, and the red clusters show where it is most common. So it is a nicely European haplogroup. So in conclusion, I'd like to say that even though it is ancient DNA, we managed to apply a new protocol and to isolate 6 samples of hairs in order to sequence the mitogenome, in order to identify the mitochondrial haplogroup, and we managed to isolate skeletal remains and to prepare the samples for sequencing so that they could go through further analysis. So we found a match between the skeletal remains and the hair from the first page of the book on astronomy. It is a similar process that was used by the Polish-Swedish team that identified Nicolaus Copernicus, who was also identified on the basis of a found hair. We confirmed the ancient age of the DNA, and my colleagues will talk about the genome sequencing. So thank you all for your attention, and thank you to my colleagues for their support and cooperation. Thank you.
I also want to express my thanks for your perfect paper. It's fascinating what my colleagues, geneticists and anthropologists, what they can do. I think that all the results were so much interesting for you that it doesn't matter that we are behind the time. We will catch up, don't worry. Because we will have a longer time for the final discussion. So I'm pretty sure that we can catch up with the time. If you have any questions now. Mrs. Fialová gave us so many details that I think there don't need to be any questions. You mentioned there was one hair, there was a piece of hair of different person. It was in the Darwin's books. So my crazy idea is that Darwin could have packed his hair into the book and sent it together with the book to Mendel, because at that time they did not have a mason to send the books. The same haplogroup, you are right. There were 2 samples from the Darwin's book, plus several samples from the book of astronomy, but the haplogroup was the same, was identical. So I can have a look at the individual mutations if it is really 1%. But your theory is quite interesting, that Darwin could have packed his hair, but not, we will verify it.
I'm Father William, and may I speak in English, please?
Yes, sure.
First of all, I am an alumnus of Villanova University, the Augustinian University in the United States. And it has a Mendel Institute. And each year, there is a Mendel medal that is award that's given to scientists throughout the world. And what I heard this afternoon, I was really very, very much impressed. And I really thank all the people for the reverence and for the care in which our brother, Gregor Mendel, was handled after his death. So that's my thanks to you. And the second is more esoteric. Recently, there's been studies done in Versailles, the Palace of Versailles, in the apartments of Marie Antoinette. Marie Antoinette, you know, the daughter of Empress Maria Theresa. And what they found in her apartments, in between the floorboards, the floor, they found evidences of hair. And what they did was they did the same testing as the trichonologists have done here. And one of the proofs that this hair belonged to Maria Theresa was they opened the tomb of Maria Theresa and they compared the DNA and they found the same thing. So I compliment the genius, you know, of the molecular scientists and the wonderful people who've really opened up the panorama of history. Thank you very much. Good.
Thank you very much for your feedback. We really appreciate your opinion and your kind words, and we are really very happy and appreciated that Augustinians support this research and in general enable this kind of research. So thanks for that, and we are very pleased for a close collaboration of Augustinians and our university. Thanks for that.
Thank you too.
Chcete ještě reagovat? Dobře.
Thank you.
Tak jsou ještě nějaké další dotazy či připomínky?
Are there any questions or remarks?
Myslím, že ne, takže je čas na
But the time is up. The time
já se domnívám, že
is up for the pause.
Ve 40.
So can we start 60 or 4:40? 4:40. We have 18 minutes. You can take some refreshments in the adjacent room, and please come back because we have still 2 presentations which will be more general and will be more about the genetics and about what can we find out today when we research DNA. So we are back and we will continue. Now we will speak about molecular genetics, which will be presented to you by Mr. Filip Pady from Genomics Laboratory in CEITEC of Masaryk University. He will describe what the molecular genetic work looks like and what can be found. Good afternoon. I need to put the respirator away to be able to talk to you. I would like to speak on behalf of the team from the Central Genomic Laboratory, which is the group which is based in CEITEC institution of Masaryk University. And we had an important task, icing on the cake in the project. It means the genetic analysis and sequencing of this precious sample, which we obtained after a long journey. So we were honored to analyze the sample. I will mention some facts which have been already mentioned by the speakers before me, but I think it will be good to repeat them from our lab point of view. I would like to give you some details about the work in the lab and about the methods which we use. I will mention the mitochondrial DNA issue and what we can use to identify the person. Then I will speak about the whole genome sequencing, which was the objective of the entire project from the very beginning, or highlight, so to speak. All the steps actually bring some obstacles, especially with respect to the quality of the sample and amount or volume of the material and so on. For those of you who are not experts on the labs, I will describe what the lab looks like and what we do. Our world is more virtual when compared to the archaeological work, because we use small volumes and tiny volumes of solutions, which actually do not tell us much about its importance. And genomic laboratories are equipped with some key tools which we use. Obviously, I'm speaking about a very clean room or space. It is quite similar to archaeological or anthropological laboratory, because these are always a sort of closed boxes which are cleaned using UV light, so without contamination, and which are actually treated with chemicals to prevent any foreign DNA in the vicinity. I also need to mention that our standards are relatively high. They do not achieve the standards which are used by the anthropologists when they work with the ancient DNA. So this is also the reason when we get the sample or in the second step, when the sample is identified and when there is no threat of contamination. Even though we use the boxes also for the patient's DNA and we need to prevent contamination. So even though recent DNA can actually spoil the ancient DNA in such environment. The key tool we are using, apart from the pipettes and small tubes, are enzymes, the development of which enables us to manipulate DNA molecule, to glue it together, to cleavage it, to propagate it, and to sequence it in specialized apparatus. This is once more the difference between recent and ancient DNA. If we compare it, our lab usually works with the clinical samples, where we sample DNA from blood or buccal swabs. So it means the tissue in the mouth. We usually get a small amount of very clean DNA, which is stored after isolation, which is stored in the fridge. And the DNA molecule can be displayed or introduced like this. It is represented by 4 letters, which represent 4 different molecules. Adenine, thymine, cytosine, guanine, which are ATCG letters, which are not really known lately. We would be grateful for such a long intact DNA molecule, which could contain several thousands or tens of thousands of letters in one fiber, which is not disturbed. But this is not the case of any ancient DNA, because it is very fragmented because of chemical and physical impacts and influence from the environment where it is sampled. Sometimes it is, or quite often, it is also contaminated by foreign DNA from the soil. You can well imagine that during the decomposing processes, there are many organisms which leave their traces of DNA in the soil. And it also causes the contamination and also the volume of the ancient DNA which can be sampled. Mrs. Fialová showed us where they isolated DNA from. I will repeat it. These are quite hard tissues which are able to preserve DNA for our usage. Hair roots, which are important for us for analysis and which we were searching for here in the Mendel Museum and which were the best source, or even the hair without the root. So in such samples, the volume of preserved DNA is quite small. So when I proceed one step further, once we isolate DNA from the sample, then we can have a look at it, not at the sequence, but we use certain methods which enable us to display DNA. And as the DNA has a good property, it means it migrates in electric field because it bears electric capacity. This is the capillary electrophosis. We have a DNA sample which we put inside, which migrates in electric current, and it is divided according to the length. The longer DNA, the more it breaks, and the shorter, the faster it migrates. And this is a typical picture of how the sample can look like. This is a sample of ancient DNA. So what we can see here are 2 peaks which are gathering with the short lengths between 100 and 200 bases. So one base is one molecule of the genetic alphabet. So it can be one of those ACTG bases. In this example, in one chain there were several hundreds. Then the chain is cut off or torn, and when the chains accumulated, it looks like this. Here we differentiate accumulated ancient DNA, and quite often what we see is a longer group, and this is differentiated on the basis of the length, because this is usually the contamination which appears there. For example, contamination from the bacterial environment which are around the sample. So within the preparation of the sample, we need to separate this. So it's good that we have this information and we can use some cleaning methods to get rid of it. And we can use especially magnetic separation. What we receive is the nanograms of isolated DNA. For the purposes of sequences, some 6 years ago, for example, we spoke about micrograms of DNA which we needed to prepare such sequencing library. So in such a short time, we are actually so much lower because we don't need so high volume just now. So this is a revolution in genomics, for example. This is something what is a good progress for us. The isolated DNA is somehow damaged or is damaged in different ways, and therefore we choose the methods which enable us to repair some of the damages. So one thing is the enzymatic repair, which we use, and later I will speak about some other methods which can be used when the first enzyme effect method was not successful. So this method is not 100% successful, but actually there is a second round how to repair the damage. Again, it is a enzymatic process. It is a mix of enzymes which enable us to remove the damages which are mentioned here. Cross-links can be actually the interconnection between the skeleton and different proteins. The bases could be damaged due to oxidation, so they look different from the chemical point of view. So these bases can be exchanged in a sequencer. There could be different fractures, one-chain or two-chain fractures. And I also need to mention that some damages can be repaired and some damages of this two-chain type cannot be repaired by sequences, because it would mean that we would need to randomly glue some parts together, and it's not possible. The other types of the damages can be repaired by enzymes. So when the input DNA is prepared, then we use it for the preparation of so-called genomic library. The library can be compared to the following situation. When you have a book, you have different pages within the book with the text which is unknown to you. This is the frequent of the DNA, which we need to read and find out about the sequence. And this unknown book can be wrapped in a cover, which enables us to have a look inside at the fragment, and the cover says what book it is, what volume, and so on, and then we are able to manipulate with the unknown sequence.
Here is a more specific demonstration, as it is usually depicted in specialized articles. This is an unknown DNA which we obtained either from an archaeological specimen or from another source, and we provide these colored endings, and these endings are synthetically prepared in the lab. They can also be ordered for the lab, and they contain important sections for us, such that are captured in the sequencer, and through these colored segments, the unknown fragment can be captured and can be made to remain in the sequencer. And they also designate so-called barcodes, and we use the barcodes to distinguish the samples. When we do the sequencing, these fragments are in billions in each reaction. And in order to make some sense of this huge amount of data and to assign some segments to samples, we use these barcodes. And last but not least, there is one more reason, and that is the key method of molecular biology. It is the Pcr method, which enables us to multiply the fragments. And in order to multiply the fragments, we need to have a known section. And this is why we have a known section through which we can copy the unknown part. I will show you a brief animation to explain how this works. In the last 1 or 2 years, it has become very popular because PCR is something that we are all familiar with these days. So let us imagine that this is an unknown part of DNA, and there are some nucleotides through which we can take a short section, and based on how the bases are paired, we use the DNA polymerases, and on the basis of this short section, it will extend the whole, or it will recreate the whole sequence. And this is repeated in several cycles, and it is the most basic way of copying DNA, so that we have more of it to be able to analyze it, to have a sufficiently strong signal. So in this way, from the primary material which we had, we created 10 unique libraries, or I should better say 10 preparations were unique, but we didn't have 10 unique input samples. There were 5 isolations, or 5 isolated materials, and 1 was isolated for the second time, and some were only reused for more preparations. The reason is that each preparation of the genome library can introduce errors in the resulting library, and this is why if we repeat the process and the error is random, we increase our chance that we discover the error if we have more preparations from one sample. Back to the mitochondrial DNA that Dr. Fialová mentioned previously. There is a clear mismatch between nuclear DNA and mitochondrial DNA, because in the cell there are several thousand mitochondria, whereas there is only one nucleus. So from the ancient material, we can get many more copies of mitochondrial DNA than nuclear DNA, even though that is what we are mostly interested in. But for the identification of the sample, mitochondrial DNA is much more appropriate. In this drawing, you can see a circular diagram, because it is a circular DNA cell or molecule, and here you can see the hypervariable areas with the high variability that can vary from one another, and this is why we can say that there are no 2 identical fingerprints, and if it is not a direct maternal line, there will not be 2 identical sequences of mitochondrial DNA. This brings me to the breakthrough discovery, that is the identification of the hair. This is a photograph of the actual hair found in the book on astronomy. From these materials, we prepared the genome library, and then we added the mitochondrial sequences, and these are the results which were yielded. And the result is a sequenced DNA, and we can show it in this way in a viewer that assigns individual sequences in this way, and it assigns them to a reference sequence, and the colors tell us where there are variances, displacements, or errors. This panel is rather colorful, and this is why we can say that the ancient DNA is damaged, which is demonstrated or manifested on one of the chains, but not on others. But we can read it many times, and the capacity of the sequencer is so high that it can read through the DNA 100 or 1,000 times, and 10,000 times, and based on that we can define the consensual sequence which can be compared against the database. And this is where we identified the haplogroup H1C and variants which clearly identify the genetic material of the hair and skeletal remains. Sequencing of the whole genome. It takes place in a way which is similar. For us, molecular geneticists, it is not so different, but the huge amount of data requires a different way of processing. The leader in genome research and practice are sequencers by Illumina, which enable us to read up to 2 billion fragments of DNA in one go, which, just to give you an idea, we sequenced 2 times on such a large machine, and in theory it enables us to read one human genome 400 times. It has about 3 gigabases, and through this huge number we would be able to read through one person's DNA 400 times and put together all the information. However, due to various reasons, the age being one of them, the coverage of the genome is lower. And this is where we go back to what I said at the beginning, that is the low input of DNA, which we can amplify and copy, but by copying a fragment which has an error in it, we copy it with the error. And in genetic analysis, we try to clear all the duplicities and errors from the data set, and we try to work with only uniquely captured sequences. So in the case of these archaeological samples, 90% of the information is redundant. So even though we use it, its use is limited. And this brings me to what part of genome of Mendel was covered by the sequenced DNA. And this is one of the outputs of mapping, where the columns show what proportion of genome has zero coverage and what proportion has some coverage. Now, the statistic is only for one sample, and I would like to expand on that. From the genetic material, we created 10 samples which were sequenced because we wanted to have individual preparation and to create the error sufficiently randomly. And now the analysis will continue, and the data from sequencing will be put back together. We will create one big data set, and subsequently it will be mapped again for the genome. This is something that's taking place currently, and this is why the statistics I'm showing here represent only individual samples for the time being. This is one of the best sequenced, but it could be, let's say, 1/10 or 1/8 of the data which will be subject of analysis at the end. So the relation is that there is 1.5 gigabases of the genome. So it is about 1/2 of the genome has zero coverage in this specific sample. And we expect that as soon as the samples are put together, they will cover the free spaces. What's missing in one sample will appear in the next. And hopefully we will get to 70% to have a sufficient coverage of the genome. But the future will tell us whether this will be the case. the future and the subsequent analysis. In conclusion, I would like to suggest what's next, what is ahead of us. It is not my domain. It is the domain of the team of bioinformatics at CEITEC, at the university. They use with the bioinformatic pipeline, where there is a sort of a conveyor belt for data, where at the beginning we input some data, and then there is a sequence of instruments. Most of the time it is some freely available instruments that manipulate the data. And if we look at the individual steps, there may be some removal of the contaminating DNA. There could be some pre-processing to remove the sequences of adapters, which we artificially added during the preparation. Then there is the assignment of sections to the reference genome. That means we try to compare to the database. Then there is for the archaeological DNA, there is a panel of tools that tries to map the damage and evaluate the damage. And the last steps aim at using analytical tools that will generate a table of genetic variants that can be further analyzed. So out of a huge amount of data, we want to create an output which, from the human point of view, makes some sense. And then we will be able to compare these variants with the databases that contain information on hereditary diseases and health conditions and so on. This other part follows up on the domain of Professor Zůbek, so I will leave it to him. So on behalf of molecular genetics, this is all. Thank you very much.
Já bych moc ráda poděkovala panu magistru Pardimu za takový.
Thank you very much for the journey into the modern molecular genetics or trip. We can open discussion. If you have any questions regarding the analysis of Mendel's DNA or a general question regarding DNA analysis, the floor is yours. It seems that it was very clear, especially the information about bioinformatics. I did not want to explain it as well. So we can move on to the last presentation, which will refer to genetics, genomics, and Mendel, but now from the prism of a physician, a clinician, who's going to speak about a genome, how we can read it, or what we have already read from gene. The topic of my presentation is the Mendel's laws of heredity and his personality. Nevertheless, I will start from the very scratch and as simple as possible. What is a genome? Genome is all DNA which is contained in a cell. I'm speaking about both mitochondrial DNA and DNA which is contained in the cell nucleus. DNA in cell nucleus is sorted or arranged in several pairs of chromosomes, 23 pairs of chromosomes in a human. The genome consists of different parts, and the coding sequences, the sequences which contain the genes, create less than 2% of the genome itself. Further, there are different sequences which are now coding, or which do not contain any genes. A human genome contains 3.2 times 10 to 10th power bases, and the genes, when we speak about the genes, there are about 20,000 genes. There are different polymorphisms, differences in the genomes of different people, one nucleotides and different polymorphisms and in the different number of the copies of the genetic material. The fact that it is important to know your genome has been mentioned here. We need to know the genome of populations, not only check genome, because we would like to compare the findings, which we, for example, find in patients with diseases which have genetical predisposition, with a standard, with a sort of standard population, and we do not have it for the Czech population. We have a special project which aims at mapping the genome of the people in the Czech Republic. The project is called ACGT, because so far we have compared all the data with the findings which we acquired or obtained from the genomes of different nations or ethnics. The first human genome information was first published in 2001, but it was not a genome of one specific person. It was a sequence of a human genome which was analyzed for several years, for a long time, and these were the sequences from different people. The first individual human genomes were published in 2007 and 2008, and the first one being the genome of Craig Venter, who is a biologist and a visionary, and the second genome was from James D. Watson, who participated in the invention of the DNA structure. The difference between these two people is in 7,200 amino acids, and then the progress was very fast. The first 1,000 human genomes were published in 2010. Since then, many genomes for diseases have been published, or genomes for different ethnic groups. The genome serves or is here not only for us to be able to learn about the genetic substance for different diseases, but with certain probability, when we know it, we can try to find out the origin of the person. In case of Mendel, we used mitochondrial DNA, chromosome Y, and mutations variants of the genes with the predisposition to autosomal diseases. So certain populations actually have more variants of these genes than different nations or populations. This is a family tree, mitochondrial heredity, and it is always inherited from the mother only. The heredity of the Y chromosome is inherited from father to son. So we could analyze both options also in case of Mendel, and then we also have autosomal types of heredity. For example, dominant, how, for example, is inherited the color of eyes and hair and so on, or different predispositions to diseases. Another example of dominant heredity refers to autosomal types of heredity. It can be, for example, autosomal recessive, when mother and father are transmitters of some variants, and with a person who has both two pathological variants, he inherits both from father and from father. And then he might fall ill. Then there are some people who actually transmit the disease, and there are some people who did not inherit this pathological variant. Autosomal dominant, what is sufficient here, what is enough, is one pathogenic allele to lead to the disease. When we speak about the origin, according to mitochondrial DNA, as I said, there is a popular scientific book which was published in 2004, and which is called The Seven Daughters of Eve. The author says that in Europe we have 7 main mitochondrial haplotypes in Europe, and there are more 29 haplotypes all around the world. And it helps us to determine the origin of different populations and nations. When we look at the 7 daughters of Eve, those daughters lived in this period, for example, 50 to 17,000 years ago, especially in the south of Europe. He named her Helen, Catherine, and so on. And when looking at the haplotypes and their occurrence in the Czech Republic, the most frequent is haplotype Helen, which is the haplogroup H, which we have already mentioned. And there are some more haplogroups, as you can see. When we speak about the Y chromosome, we also have several haplogroups here. The most frequent haplogroup in Europe, in our population, is R1a, which is occurring in Central and Eastern Europe. There is one R1b haplogroup, which is in Romanic, Celtic, and German regions, and also in Central Europe. And the next haplogroups are one, which is quite frequent in Nordic countries or German countries. The haplogroups are then divided to different subgroups. So it is a general information, a very simple one. Based on the Y chromosome, the most frequent haplogroup in Czech Republic is R1a, R1b. And the next ones are not so frequent. People having these haplogroups were also identified in the as the remains from the Bronze Age and so on. So this is actually we can say that according to the Y chromosome we are the Western Slavonic, and there are also ancestors from the Roman countries and from the Balkan and Germans and so on. The origin can be also determined according to the mutations of the genes or pathogene variants of the genes. In our population, the hematog gene for hematochrome is the most frequent, every 10%. Then Beth-Leiden mutation, which is a higher risk of thrombosis, every 20th person, heterozygon, and every 25th person is inclined to cystic fibrosis, and so on and so on. I would also mention Niemann breakage syndrome, which is quite which is typical for every 125th person of Slavonic origin. And this is a typically Western Slavonic variant which has a predisposition to certain tumorous diseases. When looking at the cystic fibrosis, this gene was thoroughly examined, and we can say that this variant of this gene is quite frequent with Slavonic people. These variants in Mediterranean, Turkish population have these variants, Celtic this. The occurrence of this variant for cystic fibrosis of this gene, you can see it is frequently found in the UK and Ireland, but it can also be found in our country and in Central Europe. The next of the Celtic variants has been found in these regions, quite frequently also in the Czech Republic. The Slavonic variant of this gene can be found in Eastern Europe and also in our population because it creates a part of CVTR gene. The analysis of the historical genomes or ancient genomes, Gregor Mendel is not the first person for whom we analyze the genome. There are more cases or more examples. The oldest one have been found in Etsy and Cheddar men. And as mentioned, Nicholas Copernicus, Maria Antoinette, Alexandra Fyodorovna, or Richard III. The genome of Gregor Johann Mendel, a lot have been said here about the analysis of his genome. As for the mitochondrial DNA, we also said that this is the haplogroup H1C. And H1C group, these are H1C 1 and 3. These are quite frequent in the whole of Europe. When we take these haplogroups as a whole, we can speak about the Western Europe, especially Spain and Scandinavian countries as well. H1C is typical, especially for the Central Europe, and for these regions to the west, it is not so typical. As for the Y chromosome, we also succeeded in identifying the haplogroup for Mendel, which is designated with RYP6376, which belongs to the broader R1A haplogroup. When looking at this group, it is typical for Central Europe, and it occurs farther to the east. Specifically, this example or this case, which was found in Mendel, has been also found in the Czech Republic and in the findings in Latvia and Scandinavian countries. And the diseases which can be inherited and their genes, we can say that there are about 5 to 10% of these diseases of all. For example, with tumorous diseases, it can be 5 to 10%, which of the diseases when the people have the inborn predisposition, which is autosomally dominantly inherited. We focused our attention to just a small portion of the genes. These are the genes which are typical for frequent diseases, hematochromosis, cystic fibrosis, Bett-Leiden, or these are also predispositions to certain tumorous diseases such as MYH9, these genes, MYH9, and which are typical for the tumors, ovarian and breast tumors. With these genes, we haven't found any pathogenic variants or variant about which we could say that Gregor Johann Mendel had the predisposition to. Apart from RUNXY, which can be a pathogenic variant, which is associated with blood diseases. But this is just a small amount of genes out of those 20,000 which are in a human.
Běžně podrobili nějaké analýze.
If we look at Mendel and his diseases, it is said that from his young age he had mood swings, and from the 80s or 1880s he is said to have morbus brichti, which is a disease which at the time was characteristic. It was typical of proteinuria. He had hypertrophied heart, and there was a lot of residual protein in the blood, so there was probably nephritis or glomerulonephritis. And he was prescribed digitalis, quinine, and morphine. And the first known prescription is from 1883. So if we know this about the diseases of Mendel, in the following research we will focus on genes that could be associated with some of the diseases of the kidneys to which he could have been prone. This is an example of one of his prescriptions. It is digitalis, which was used for heart failure. So this is all from me, and I would also like to thank my colleagues from CEITEC and bioinformatics who helped us with all these analyses. Thank you. Thank you, Professor, for a slightly different view of Gregor Johann Mendel, his origin and his health. Now we have a chance to ask some questions. I think you can ask not only Professor Zůbek, but all other speakers as well. Since the Mendel family came from Germany, south or southwest Germany, the results of the haplogroup of Y chromosome are rather surprising for me. Of course, it is not conclusive, but it's interesting. It is all a speculation. What chromosome comes from where, but the so-called Slavic mutations of the genes for cystic fibrosis are often found in the eastern part of Germany, where there was a long Slavic settlement. And I'm also a hematologist and a donor of donors of bone marrow often come from the eastern part of Germany. So I don't think you can divide the haplogroups by borders. I think that the transitions are much more vague. Any further questions? I'd like to ask about something very specific. From what age did Mendel use morphine? Is it known? And how does that go with his scientific career? The reason I'm asking is that I've got experience with other opiates and scientific career under the influence of these medicaments. As far as I found, he was treated with the morphine in the final months of his life. Morphine is a drug used to suppress apnoe because he had heart failure. Are there any other questions?
Tak já myslím, že se pomalu můžeme blížit k závěru a já bych ještě ráda...
If there are no further questions, we can conclude this session. And before I close this session, I'd like to express my thanks to Gregor Johann Mendel, who is watching us from this painting on the wall. And I would like to thank him not only for laying the foundations of genetics, this very interesting scientific discipline, but also for inspiring so many scientists and researchers at Masaryk University and this very interesting research. New methods and new technologies are being used in this research, and Gregor Johann continues to be an inspiration and someone who brings new stimulus to science. And in conclusion, there is a small surprise. We find ourselves in the refectory of the monastery, and we are close to Mendel's museum. And unfortunately, the director of Mendel's museum, Blanka Křížová, wasn't present yesterday. And she is someone who was very active in the preparation of this conference, but unfortunately she had to stay at home because of quarantine of COVID in the family. However, she would like to say a few words, and she would like to be with us for a moment, at least online.
Dámy a pánové, krásný večer.
Ladies and gentlemen, good evening. Can you hear me? I would like to extend my cordial greetings. Unfortunately, I'm not able to be with you today. I'd like to thank the team of Mendel's Museum and everyone who helped to prepare Mendel's Days. I was watching the whole event online, and technically it was very well handled. So thank you to Muni TV. I want to thank everyone who cooperates with the Mendel's Museum and the whole team and the Augustinian Abbey with which we are cooperating on many projects. Mendel's Museum is preparing many events for the upcoming celebrations of the anniversary, and we are preparing an exhibition on genetics, and we've also prepared a comic strip on genetics, which you may be able to see. And we are preparing some educational programs for the general public and for schools. Now, I would like to invite you to a concert which will start in this room at 8 o'clock, and it will be given by Societas Incognitorium and Pacora Trio, and you will hear Ovidius's poems in music, and then there will be a combination of jazz and old music originating here in Moravia. So enjoy the rest of the evening. Now there will be some refreshments in the Cistercian refectory, and I hope you are going to enjoy this evening. Back to you. Thank you again. Thank you very much for the preparation of this event, and thank you for your kind words. I will join in with the invitation to the concert that starts at 8 o'clock, and even those who are at their home screens now, they still have enough time to get here to the old Brno Abbey, to the concert which starts at 8. Today we spoke several times about the preparations of the 200th birthday of Mendel, and as part of these celebrations we are preparing an international genetic conference which will take place in July next year, specifically from the 20th to the 23rd of July. That is exactly on the days when we will be celebrating the birthday. And I think that it's going to be a very interesting conference because the invitations were accepted by excellent speakers, including 3 laureates of Nobel Prize, Tomcech, Adajonach, and Polnars. And there will be many other outstanding speakers, such as Gymnase from Oxford, Jan Korbel, and many others. So I believe that it's going to be a very inspiring event, and if you plan your summer vacation, please remember that from the 20th of July for the next 3 days, it will be best to stay in Brno, because this is going to be the focal point of the genetic world. I will ask my colleague, Mr. Hanuš, whether he has any further information. I just wanted to point out to the presentation of Blanka Křížová. Thank you, Blanka, for everything.
Já také ještě jednou děkuji. A nyní bych vás všechny moc ráda pozvala na...
Now allow me to invite you to some refreshments which will be served in the refectory of the Cistercian sisters here in the Abbey, and during some refreshments we will enjoy the time before the musicians prepare their instruments for the concert in this room. So it is worthwhile to attend both the cocktail party and the concert. Thank you all for coming. Thank you for the discussion. Thank you for the lectures. And let us move on through the outside courtyard to the refectory, where we can continue our discussion in an informal setting. Of course, we will talk about Mendel and his legacy. Enjoy the evening.